technology. This is involving people. This is crowdsourcing. This is Haiti. Well known in this moment after Haiti. A couple of young people, completely black with one white guy, and they programmed an environment where people could give their input bottom up. However, I think that we need more than just bottom up. So I like to discuss with my colleague how we can cooperate, because I would really like it. Rob and I discussed together how we could solve this problem of language, and I was happy that Jack Dangemont helped me. He said, I have a very old professor. Jack is already old, but this professor was even more older, Carl Steinitz. And Carl Steinitz told me that he was writing a book. He was writing a book about bringing disciplines together. And he was calling it Geodesign. Like GIS, nobody had heard about it, a new word, what can we do with it? And that's what I like to explain to you. Geodesign. Information technology is an important component. Different disciplines, like geography, like design, and of course we need scientists like this morning. But in the end, you heard the story already, it's all about the people of the place. That's the reason that we do this. This is why it becomes smart and how we bring this together. This is the first time that we brought scholars and scientists from all different disciplines to Europe to discuss geodesign. And it's strange when you organize something like GeoBin, you have to find the people who are willing to give it a start. And that's also the case when you talk about geodesign. So how do you bring people together who will be the first discussing, let's say, this new language? I think we were able to do that. And we brought a lot of people who want to improve, let's say, our society. And people from different countries with all, let's say, the same attitude. We all think that things have to change. To change in the way we communicate, we cooperate, and how we use technology. And of course, the good news, the technology is developing very fast. And that means that all the wonderful instruments and all the data is becoming available, and it becomes open data. And that's of course crucial. Can we get access to the data? And then the next step is, of course, can we use technology for doing something with it? So having the altitude data, and we have the registrations, then we can combine the two, and then something is going to exist. So we call this 3D data. Shall I push the button? That's easier for you. So we call this 3D data, and some of us, the specialists, are very happy, because this really looks like 3D. But the architects are not happy at all. So they are asking, can you improve it? And then we made a huge step. They still don't like it, because they think about 3D in this way. And Herman already said that level of detail is crucial. How can we combine the two? Because when we asked an architect, I was really shocked by that image this morning from Trimble about the environment. This is the environment of an architect. And you think it's not serious, but it's really serious. This is a famous architect from the Netherlands. We have a different feeling. We think that we have to combine the two. And the good news, it's possible. And it's very accurate. It immediately opens the possibility to talk to each other. And now we bring in the famous planner you just saw from Amsterdam. And we tell him that he can use this technology. So that it is possible to look around with new instruments. We call it a big iPad Touch. And it's possible to take that wonderful building made by our famous architect, and we bring it, in this case, that's because we have some visitors from The Hague, we put it in The Hague, because there's still a lot we can improve in The Hague. It's a wonderful city, but let's put that building there. And now you're going to ask, have you done that already? Yes, I show it, there it is. The question is, of course, immediately, what are the consequences when this is possible? I take it away because a lot of policy people will not like it. So at the moment that you have done this, you have to know what it means when we are planning in a way like this. So the buildings who are out of sunshine, the improvement or the number of cars. So a lot of key performance indicators makes it possible that we have a new way of sharing information, sharing standards, because otherwise it would never have been possible that I bring the two worlds together. And the big question is, will this help us in improving, making the city smarter? Of course, we can use another technology like glasses. Now you have a 2D screen and you can look it from the, let's say, above part, but also from the soil part. But Martin will tell more about that this afternoon. What is it what I try to tell? I think that making geodesign a common language, we need standards. We need an environment which is easy to handle, because the first time that Herman made the AN2 or 3 available, people got terabytes. Nobody knows how to handle terabytes. So it has to be based on the real world, it has to be based on standards, it has to be open, but it has also to be accessible. And that are the two recipes I like to discuss today. One recipe is called the GeoCraft recipe for children, and the other one is for adults. And given this room, we decided to go for the adults. GeoCraft and Minecraft, that's for the children. So this is a movie where you see that we can bring the whole 3D world into an environment, Lego, where we can ask children to be involved in our discussion of cooperation and collaboration, but what's more important, to think about their own future, their own environment, and play with it. Because that's what we are also doing. So can we play with this wonderful information you are all bringing together with your new technology, and can we make the children happy? Can we make the children involved? However, that's up to Martin this afternoon to talk about children. We are taking you very seriously, so we're going to go for the adult part of our recipe. And this is a wonderful movie, but I'm afraid you will not hear the sound. But it's about 2040. It's about the Ministry of Traffic and Transport. This is something which comes from the Ministry of Traffic and Transport. This is a game. This is a game about the future. This is a game about bringing data together for all these Rijkswaterstaat people. Because these Rijkswaterstaat people have to talk and discuss the future, like we all have to do. But how can we do that? And this is a trailer of a movie. But we are not going to listen to the movie. I brought somebody with me who can play the movie. Michel, can you tell me a little bit more about the movie?
I'm going to talk to you about megacities on the move. Maybe you've heard of it, maybe not. But this is from 5 years ago already. A report stating 4 cities, 4 possible scenarios for city development in 2040. We've taken this report as a starting point for Amsterdam, Almere, Utrecht and the floating city, and to build those cities based on this report in how they will look like in 2040. And this with respect to energy, transportation, food production and how the city will look like. We've put these concepts into a serious game called RWS Imagine. And in this game, it is the goal to discover the policy measures that has led to these scenarios in 2040. So you see the city in 2040. We're going to play the game in a few moments. And then the policymakers have to discover all the objects that has led to these scenarios. And it will become clear in a moment. So it's basically a treasure hunt game. You have to find all these concepts and the team. And the game is designed to be played on 4 large touch tables with 4 teams. And the team that finds the most objects wins the game and gets a little trophy. well, the 4 cities, for those who are not familiar, Amsterdam, Utrecht, Almere, and in the blue there will be a floating city, and that's the one I will show you. But first, I'm going to talk about how we built this game. First, we used Autodesk Maya to create some assets, because in some scenarios there are drones, which are the main mode of transportation for small goods, or for example nuclear plants or fossil fuel plants. All these assets are imported into City Engine, in which also the cities are designed. So the road network and also the city layout is built in City Engine. This is how one of the cities looks like. All the red objects have to be found. These are the assets. Then we go to Unity. Unity is a gaming engine, and Unity is very suitable to add animations, traffic, gameplay elements. And then it looks like this. This is Amsterdam in 2040, according to what we think it will look like, but based on megacities on the move. And via Unity it can be exported to the Unity web player. Then it looks like this, and I will start it up in a moment. And first I want to show you this. These are the four cities we have designed based on, along the main axis of megacities on the move. You've got the energy source, fossil or renewable, and the governance. We're going to look at this right bottom one. So it's a clean city, but it's bottom-up governance. And bottom-up governance means that it's very community-based. So you have all neighborhoods in which everything happens. So energy production, food production, it's all community-based. There are 4 islands, which are the communities, and in every island you've got your farms, you've got all the necessary ingredients to live sustainable. And for example, all the yellow things are clickable and have to be found. So for example, if I click on this one, which is, here you see it, you see these white things flying. Now they are white because I've clicked on it. Those are flying pods, and we have then on a second screen, if a policymaker clicks on that, on a second screen an information card turns and it says the corresponding information, such as in this case rail traffic is not longer needed because everything is community based, so there's very low traffic, and people choose to use clean self-riding small transport vehicles like these pods. So it tells the policymaker, well, this city is clean. It tells something about the policy measures, the rail network is gone, and people are allowed to fly in these things. And it tells something about technology, because they are self-flying. And so you have 21 objects throughout the city that has to be found. And that's basically what I wanted to show you. I give it back to Henk.
Thank you very much, Michel. This is much more than a game. This is a discussion between the people on the highest level within the ministry. It's something where they have put an enormous amount of energy, because all these scenarios are coming from, let's say, different departments within the ministry. And we have tried to bring it all together. We have tried to bring it all together in an environment based on all the data we collected. Of course, here's design an important part, but we always start with the world of today. So when I go back to our conclusions, then I have showed you, or we have showed you, 2 examples in which we have used all the possibilities of today. And we brought it together, all this data. We have integrated the data. We use our scientific knowledge. We use all the wisdom of the people, in this case, of the Department of Herman. And we do this because we think the involvement of people is crucial. We call it public participation. When we talk about younger people, we can also talk about education. We think it's crucial that we learn people to think spatially. And that's not by just giving them an atlas. They have to play with it. They have to do something with it. And we hope that with these workshops we are able to make progress in thinking smart. Bringing, let's say, other concepts on the table. It's still based on the fact that we are able to bring all the data together. So at this moment, 70 million children are playing Minecraft. Why should we not give them the real world instead of their fantasy world? Let's do both. But let's give them all the data we have collected together and all the technology we have. And I am sure that we can leverage their motivation and creativity. And I think you will see wonderful examples also this afternoon. The next week we have a meeting with the minister where we can bring, let's say, the results of what these children have done in the last couple of months. And I'm sure she will be very impressed. Question, is this a new GIS generation? Yes, it is. It's a complete different approach. We are talking about terabytes. We are using simple viewers where we stream all these terabytes. That's for us GIS people a miracle. For the game engine people, it's daily base. It's normal work. Why should we not use terabytes? And why should we not use 3D? Of course, we can use their wisdom. We have to speak also their language. But the next generation is already speaking their language. And is it a new way of teaching? Then we first have to explain that to the teachers, because they are the biggest hurdle at this moment. So we have to help them. And I think it will make our world a little bit smarter. Thank you very much.